we're going to solve these just a little bit differently. Like we said yesterday, we solved the system of equations by graphing. Today, we're going to solve them by substitution. So right up here where it says notes and examples, guys, we are still dealing with system of equations, okay? Just like math, there's always a couple different ways that you can solve, okay, to get your answer. Yesterday, we determined if there was one solution, no solution, infinite solutions. You determined that by graphing, whether they were parallel, intersecting, same line, okay? Well, today, guys, we're going to do it by substitution method, okay? What's another synonym for substitute? Single word. Replace, okay? So you guys know before with substitution a lot of times, and I'm just going to give you an example here. Before, you may have an example that was like y equals 3x plus 4, okay? Now, if I told you x equaled 5, could you solve that equation? What would you do with 5? You would substitute it in for what? X, okay? So that's the same concept that we're looking at today. Same concept, except we're going to take it a step further, guys, and it's not going to be just a single number, okay? So the substitution method, guys, it is a method of solving equations, solving system of equations by substituting equations within one another. I'm going to fix my spelling. Okay, so it's a method of solving system of equations by substituting equations within one another. Okay, so there's a couple steps here, guys, and the steps are kind of wordy. They are just a little bit, but it is simple substitution. Okay, so looking at the steps, guys, solve one equation, and we can solve these for x, or we can solve them for y. Okay? Step 2 is you're going to substitute this expression into the other equation and solve for the variable. Okay, so basically what it's asking you to do when it says solve one equation for x and y, all it's trying to get us to figure out x equals this or y equals this. The easiest way for me to tell you guys is to just solve an equation and put it in slope-intercept form. Okay, that's the easiest way for me to explain it to you. All right, now the next thing, step 3. You're going to substitute your answer. So whatever you get, you're going to substitute that answer into the revised equation from step 1. And solve for the other variable. All right, so we've got, on number 1, guys, we've got 2 equations. We've got a system of equations, one that have the same variable, and we have multiple equations. Okay? So, like I was telling you earlier, guys, we are simply going to take one of the expressions that y equals and substitute it into the other equation. So we have y equals 4x minus 1, and we've got y equals 2x minus 5. For me, just simply, it does not matter which one that you go with. What I like to look at is which one's going to be easier most of the time. Okay? Some of them you'll be able to tell, some of them you won't. Like this one, I don't think it's going to make a difference. They're both kind of simple equations / expressions that we're going to use. So the first one that I would do is I'm going to take, you have y equals 4x minus 1, and then you have y equals 2x minus 5. Okay, I'm going to take the y equals 2x minus 5, and substitute what y equals into y for the first one. So we're going to end up having 2x minus 5, because that's what y equals for this equation. So we'll have 2x minus 5 equals 4x minus 1. Okay? Now, again, this goes back to what we did the first couple weeks of school, solving basic equations, solving multi-step equations, solving equations with variables on both sides of the inequality. Okay? So simply now, this goes back to, like I just said, solving equations. You're going to move your variables to one side, isolate them, and then solve for them. Okay? So for me, I'm just going to move my 4x and minus 4x. Okay? Those are going to cancel, and you have a negative 2x minus 5 equals negative 1. Okay? Now, I'm just going to draw my little arrow. Let me use my text box. We have a negative 2x minus 5 equals that negative 1 right up there. And I just rewrote it so it'd be a little more legible. Okay? Now, again, same concept. We're still trying to isolate the variable and solve for what x would be. So we're going to remove the constant, do the inverse, which is going to be plus 5, plus 5. Okay? Good. Those are going to cancel. And we are still left with a negative 2x equals a positive 4. Okay? So, now, still solving for x, like you guys know how to do. Divide by negative 2 and divide by negative 2. And that's simply going to leave me with x equals what? Negative 2? All right, now, so we have x equals negative 2 now. So now instead of having to substitute a whole expression into the variable, now we can simply solve for y by substituting in just what x would be. Now, you can choose either one of those. You're still going to get the same, or you should, same answer either way. All right, so take your negative 2. Do y'all want to do the first one or the second one? Sure, first one. So we have y equals 4. That's going to be times negative 2 minus the 1. All right, so you guys know 4 times negative 2 is what? Negative 8. And then negative 8 minus 1 is what? Negative 9. So y equals negative 9. All right, we have an x value and a y value. When you have an x and a y together and you're talking about equations, linear equations, and graphing them, you would call that an ordered pair. So we have negative 2, comma, negative 9, comma. Now, how many answers did we get for x and y? How many answers did we get for x? How many answers did we get for y? 1. Think back to yesterday. You would call that how many solutions? How many answers did we get? 1. 1 for x and 1 for y, right? So that's one solution. If you were to graph these equations, what type of lines would you give? They would be intersecting. That point where they intersect, obviously it would be where? At negative 2, negative 9. Okay? All right, number 2, guys, again, we've got 2 equations, one of them in slope-intercept form. Looks like the other one's in standard form. Okay? Now, for me, this is what I told you earlier, guys. Whichever one is the easiest to substitute, that's what I would do. Now, do you guys want to take that second equation out of standard form, put it into slope-intercept form, and then substitute it in for x or y? Or would you rather just take that 6x and substitute it in for y? I think that's the easiest way. You can do both. You'll get the same answer for both. You should if you do it correctly. But for me, I would rather just take that 6x right there and substitute it in for y. Okay, so what we'll end up having is we'll have 2x plus 3 parentheses 6x, close the parentheses, equals negative 20. Okay? So we didn't have to simplify, we didn't have to move, we didn't have to put in slope-intercept form, we didn't have to do any of that. Okay? Make it easier for you. Now, again, this goes back to what we did the first couple of weeks of school. 1, solving equations. 2, distributing, combining like terms. Okay, so we have to distribute the 3 to the 6x. Okay, and that's going to give me 2x plus 18x. Good, and that's going to equal the negative 20. Okay, again, going back to what we've been doing. First couple weeks of school, building, combining like terms. 2x and 18x is 20x equals a negative 20. Okay? You guys being smart like you are, you guys should know that negative 20 divided by 20, x is going to give you what? Negative 1. Okay? All right, now, that was pretty simple and pretty easy. Do you guys want to substitute this negative 1 into the first equation or the second equation? First, definitely. Okay, that's what I'm saying. Make it easy on you. Okay, so take that negative 1, substitute it in. So you have y equals 6 times that negative 1. Close parentheses. So y equals 6 times that negative 1. So y is going to equal negative what? 6. All right, list your ordered pairs or your coordinates. You have one solution for x and one solution for y. It can't be anything else. If you were to graph that, what type of line would it be? Intersecting. Good. So, negative 1, comma, negative 6. All right, y'all good with that? All right. All right, we're going to add just a couple more notes, and I want these to go under your example columns. Okay? If you are solving some of these equations and you get an answer where it may be 5 equals negative 2, or it may be something where you get 5 plus 6 equals, 9 minus 7. And you're looking at those two. Does 5 equal negative 2? Does it? Okay. All right. Does 5 plus 6 equal 9 minus 7? No. Those are not true statements. Okay? So what would you say about those solutions? They are what? It's no solution. What type of lines would those be? Think back to yesterday. Yesterday we had one solution, no solution, infinite. What type of lines would they be? It would be what? It would be symmetrical or parallel. Okay? Now, which is going to my next one. Okay? If you have, let's say, 5 equals 5. Or let's say you had 7. Again, these are just examples. Plus 2 equals 9 plus, let's go, 8 plus 1. Are those true statements? Those are true statements. What do you notice about both sides of those equations? Don't say they're equal. I want you to say a more simple term. Anybody? Are they the same? Yeah, so what type of line do you think they're going to graph? Same line. So what type of solution would that be? Infinite. Okay? My spelling is terrible. Okay? Infinite. Okay? So if you get something that looks like that, it's a no solution or it's an infinite. Okay? Now, what you guys are going to do, you're going to complete 1 through 11. I want you guys to circle numbers. I think it's 7 and 9. I think it's 7 and 9. Circle 7 and 9. Those will be something different besides one solution.